Hi, I'm Paul Germain, and welcome to another session of Smart Boating. As you know, if you watched the show before, we cover a variety of topics, from man overboard to marine insurance. And the general idea is to give you a little bit of information, help you make smarter decisions, and have more fun on the water. And this show is right in line with that kind of thought train. It's on the repair and refurbishment of propellers. And we're here at Accutech Marine Propeller in Dover, New Hampshire, with the owner, Larry Kinberg. Larry?
Morning, Paul. Thanks for coming out.
Thank you very much. We're going to have a really cool show here today. But before we get into it, can you share a little bit about your background in boating and how you get involved in the world of propellers?
Well, I bought a boat. That's how I got into propellers. And we wound up buying a new boat, and it vibrated when we bought it. And we ultimately found out it was in the propellers. And nobody could answer our questions. Nobody could solve the problem.
Interesting.
Until I made a phone call to Australia, to PropScan. And the owner picked up the phone, Terry Ryan. The man spent an hour and a half with me on the phone explaining why I was getting the vibration in the boat.
Really?
It was from the propellers.
Wow.
Even though it was a new boat. And so he said, get the props to a PropScan shop, which I did.
Yes.
We had the props tuned and set up, and all the vibrations disappeared afterward. My fuel consumption dropped, my speed went up. Everything he said would happen, happened. And then he invited me to purchase his equipment and set up a prop shop. And I said, Terry, I know nothing about props. He says, you're perfect, no bad habits. So we started in 2001. I went to Australia in September of 2001. 3 weeks of intensive training down there, hydrodynamic training, propeller training, everything. And came back. We opened the shop in October of 2001. And this is our 18th year.
Wow, that's quite a story.
Well, it is. It's been a road, and it's been a fun road.
I bet it has. Well, you obviously know a lot about propellers, which is perfect for the show today. So why don't we get right into it?
Sure.
Okay. Larry, when it comes to the world of propellers, it's a lot to learn, a lot to cover, but we can't cover it all in a half-hour show. But we can cover, I think, the most important points for people. And I thought maybe we'd start off with some definitions so people understand. They think about propellers, they've heard of diameter and pitch. You've got a propeller here. Can you help people understand what those two definitions are and how a propeller works?
Certainly. Propellers are categorized based on diameter of the propeller and the number of blades and the pitch of the propeller. Now, diameter is very important. Number of blades is very important, and this blade surface area is important because that's the traction to the water. That's what transmits the horsepower to the water. Your pitch, which you really can't see pitch. Pitch is calculated. What you're seeing here is blade angle to the water. So pitch is calculated, and that's expressed as, let's say, it's a 24-inch pitch propeller. That means that in a perfect world, for every revolution of the propeller, you're going to move the boat forward 24 inches. But there's a problem with that because we're working in a fluid environment. And there's what we call slippage.
Some slippage,
And that slippage is expressed as a percentage. We want the lowest possible slip. So in designing a propeller, we want the largest diameter, slowest turning, to get the smallest or least amount of slip for the propeller. That translates to efficiency. So diameter and pitch, two numbers on a propeller. So when you look at a propeller, the first number is the diameter, then the second number is the pitch.
And every boat or engine combination, they'll typically have like a recommended range of diameter pitch, I would guess, right?
There are for outboards. With the inboards, it's a little bit different process because we have to calculate that differently based on gear ratio and horsepower. And that's done the same way on the outboard, but it's a little bit more complex.
All right. Well, you've got a nice new prop there, and we've got some other ones here that aren't as nice, right?
No, they have problems.
They have a problem. This blade looks pretty ratty right here. It's got really chopped off. That could have been, a rock they hit. Maybe at high tide they went out, low tide they came back in. The rock was that close to the surface and clipped the blade, right? Or Here's another one here. This is a stainless. It takes a lot to bend stainless, doesn't it?
It does. The stainless is a thinner material than the aluminum, but it's also much stronger.
Okay.
And this one obviously hit some rocks.
Yes.
You can see by the scratch marks
yeah.
on it.
Yeah.
And that's typical damage that we see on stainless steel propellers.
Is it?
Yes.
Yeah. So they don't fail, they just bend.
They bend, whereas in
Yeah.
an aluminum, will tend to more break off. They will bend too, but we see much more breakage here than we do in the stainless.
Okay, all right. So these are some of the examples of what you get. Now we're going to move from here into kind of the process you use when we come into the shop, right?
Yes.
Yeah, okay, good. Well, Larry, when a prop comes into the shop, the first thing you've got to do, I guess, is get it cleaned so you can do an accurate visual inspection, right?
Correct.
Yeah, all right. And we've got a prop here, which is a good example of what comes in. And let me hand this to Mike, because Mike works this machine, right?
Mike works this machine.
Can you explain what's cooking here?
Sure. What Mike's going to do is put it in the glass bead cabinet. And the glass bead cabinet is like a sandblaster.
Okay.
And it will clean off all paint, corrosion, anything like that on the prop. It takes about 10 minutes to clean a prop.
So he just moves that sand gun around.
Yep.
To clean the prop.
Yep.
That's going to get all the old paint and debris off it.
Yes.
Give you a really nice surface to do a visual on.
Correct.
Yeah.
Yep. Okay.
All right. Well, that should be about good.
That should be good.
Shuts it down. Now that's our other prop. Let's show an example of what that typically comes out to look like.
So when it comes out, you can see that it's nice and clean.
Yeah,
we get off
right
most of the paint. A lot of this paint doesn't come off because it's powder coated, so it's very difficult.
Yes,
but we get it as much off as possible. That way we can check for cracks or defects, anything in the blades.
Right. Perfect. It's a great place to start, right?
It is.
Right. Larry, once you've done the visual, oftentimes you'll see inconsistencies in the pitch of the blade, right? So how do you go about getting the pitch back to the factory specifications?
Well, there are what we call pitch blocks. These are machined specifically to a typical manufacturer's propeller.
Okay.
And this is set to a certain pitch. Now we have a propeller here that is in pitch.
Okay.
This one's okay.
That's correct, yes.
This one's correct.
Yeah.
And here we have the pitch block for this brand propeller and this pitch. What we're going to do is set it on here.
All right.
And we're going to move it over to the pitch block here.
Okay.
And you will notice that it conforms to the pitch block and there's no gap between the pitch block and the blade.
It's a nice tight seam.
Nice tight seam.
Yeah.
And we'll check all blades to make sure that they fit that way.
All right, all right.
In a prop that is damaged, such as this one, you'll be able to see that there is a gap.
Yeah,
and there is a gap right here.
If we move it, we can hear it because it's not laying down flat.
Correct.
Yeah.
So what we'll do is Xavier is going to demonstrate how we straighten that out and how we conform it to the pitch block.
Okay, all right. And you've got a hammer and a strap, huh? Okay, what happens? He puts the strap underneath the prop.
So he'll do this several times and check it until he actually gets it to conform to the block.
All right, it's an iterative process. It's not a one-time.
It's not necessarily a one-time, and you'll see that it's starting to come into compliance now. We're losing that gap, and he'll just keep working it from there.
All right. So some props you can probably get away with this, right? That they're okay in okay shape. Just the pitch is out. Other props got rugged edges. Edges which has been broken off, the tip's been broken off, and there you need welding, right?
Correct, yes.
Okay, all right. So that'd be the next step on a prop like this.
The next phase, once we get the pitches in line, we're going to take the prop over to the welding booth, and we'll build up all this metal here or repair any damage on the edges that need to be welded.
Okay, okay. Well, Larry, some of the props that you get here in the shop need welding, and it's a multi-step process, right?
Yes, it is.
Yeah.
This propeller has just come from the pitch block area, which we just saw. And the pitches have been set on the blades. And as you can see on this particular blade here, there's some damage that needs to be welded.
Okay.
Mike, our welding specialist, will then take and make a pattern of the good blade.
Oh, I see.
And
okay.
he will take, which you can do now, Mike, is make a pattern.
It's a fairly simple process, isn't it? Just putting a piece of paper over a blade, but
Right.
simple but effective. Right?
Yes, but we have to make sure that the blade is correct, that we're patterning,
Okay, yeah.
so that all the other blades are the same.
I see. Okay. All right, so we do that, and then we tear that piece of paper.
Now we have a pattern of the good blade.
Yes.
Now Mike will go into the welding process and weld up the damaged areas.
Right, right.
And
Which we
this-
can't show today, it's just
Right,
the light's too bright.
Right.
Yeah.
But you can see how the weld has been built up. The blade has been built out larger than what it should be. That's
okay,
why we
you
need the
oversize
pattern.
it.
We oversize it. That's why we need the pattern.
Okay.
So now that he has a pattern, the welding is done, we can take the propeller into the grinding room, grind the weld down to match the blade, and he can use his pattern to make the blade shape identical to the others.
Beautiful. Well, Larry, grinding is a pretty basic process, but it's a very important process when you're working with propellers, and we're in the grinding shop. What's he going to demonstrate for us here?
Well, we've welded the propeller, and he's going to grind out this weld to match the blade, and then we're going to check it with the pattern we made.
Okay, so
So-
let's let him grind. Let's step out of the picture for safety reasons
Yep.
and come back in.
Right.
Okay. Perfect. All right, Larry.
Okay.
Now you've got a pattern in your hand, right?
I've got a pattern in my hand, and we have two blades that have been repaired, and you can see how the pattern, these have been ground and repaired,
Okay.
and you can see how the pattern fits that at this point.
Beautiful.
And we would check each blade, and from here, it would go to balancing.
I see. Okay, great. Well, Larry, you know, one of the processes towards the end, or one of the activities towards the end of the process is the balancing of the prop, and you've got these different pieces here and this different, simple, but actually very accurate machinery, right?
This is very accurate. This is called a stir balancer. It produces absolutely no drag when you're doing the balancing, so we can get a very, very accurate balance on propellers.
Really? So you mount them on these shafts, right, with these spacers?
We have spacers, we have arbors for all the different propellers. The one that you're holding now is for an inboard propeller.
Okay.
We use this type for the outboards, which is more adjustable because there's more variation in the hub lengths
Really?
with the
Okay.
outboards.
So you mount it on this, you put it in the machine, and then what do you do?
Then what we do is we check for a heavy blade. And like I said, this one's been ground and patterned, but as you can see, the propeller's moving on its own.
Yeah, would that make a difference underway?
Underway, that would produce a vibration that you would feel.
Okay, all right.
It would also create a problem with water getting in through the seals of the lower unit of the
Right.
of the
Of the outboard.
motor of the
IL,
outboard.
Right, yeah.
So what
yeah,
we have
yeah.
here is we can see that we have a blade that's dropped to the bottom. This was
Yes.
what we call the heavy blade.
Okay.
So we would take and mark it as a heavy blade.
Oh, okay.
At this point, it would go back into the polishing room, and we would take a Scotch-Brite pad on a buffer and just remove a slight amount of metal from the suction side of the blade and we come back and put it back on the balancer until it doesn't move again.
So two things I'm hearing. One is a very, very slight amount of material being removed and a certain side of the blade as opposed to another side.
Yes, it's very important when you balance a propeller to remove metal from the suction side of the blade and keep the contour of that suction side.
Okay.
Otherwise, it throws off the performance of the propeller.
Oh, all right, all right. And now, is this an iterative process as well? You do it here, you go make the adjustments, and you bring it back. Does it sometimes take a couple times to fine tune it into the right place?
It does. It becomes an art form. Our guys get very good at doing it in a short period of time.
Right, and this has a really big payoff.
Yes, it does. This is what makes the propeller run really smooth.
Right. Well, Larry, the final process, once you've got things, the blades in the right pitch, and you got things ground and polished and balanced, is actually painting and prepping it for shipping, right?
That's correct. It's completed now and painted and ready to go to the customer.
Yeah. So this is the final process for the outboard prop. Now we're going to look at inboard props.
Let's do it.
Okay. Now, we've been talking a lot about outboard props so far, but you know, you get inboard props, and the distinction I'm making here is aluminum, stainless steel versus bronze. And you see a lot of bronze. You don't see so many bronze on larger boats down the ocean, but you see a lot of bronze here because you got a lot of lake boats and you got a lot of large boats too, right?
Well, we get bronze propellers. There are two types. There's bronze and there's nickel aluminum bronze, but we get them from the coastal area, actually from all over the country.
Oh, you do?
And all sizes from 6 inches up to 68 inches in diameter.
Okay.
So we do see a lot of the bronze or inboard
All right.
style
And
propellers.
the way the process starts, that would be similar regardless of the propeller, whether it's aluminum or bronze. You start with the glass bead cleaning.
Yes.
To be able to put yourself in a good position to do a visual, right?
We need to inspect the propellers, so they need to be cleaned, and then we need to get into a lot more detail with the inboard propellers than we do with what you just saw with the aluminum.
You do? Okay.
Yes.
All right. Well, let's go take a look at that.
Yes.
Well, Larry, once you receive the props into the shop, we got them in inventory, you've cleaned them, done some that glass bead cleaning process. I guess the next step is a visual inspection, correct?
That's correct. We bring the propeller over to either the prop scan or the MRI. And what we're going to do is we're going to mark down any defects we see on the propeller. We're going to do a very close inspection.
Okay.
Inboard propellers are a lot more critical than what we just went through with the outboard propellers.
Really? Okay.
From many different aspects. But one of the most important things is how is the propeller running on the boat?
Okay.
And we want to have that conversation with our customers, with our boat owners, to know that the propeller is properly matched for the boat and it's getting the best efficiency.
So you want to get a lot of data in, like how big the boat is, what sort of load it's carrying, maybe what sort of conditions it operates under, that sort of thing?
And how they're using their boat.
Yes.
Are they fishermen? Are they just cruisers? What are they going to use the boat for?
Okay.
We
All
want
right.
to be able to dial the props in correctly for the boat owner. It's going to
Yes.
give them a much better experience.
Yes, yes.
But in the initial inspection, we have a 3-bladed propeller here. This is a manganese bronze propeller.
Okay.
And this one is set up on the prop scan. And what we're looking at here is you can see this pink.
Yes, like a little spot.
Like it's an indentation
sunspot,
here. Yeah.
kind of.
And we have more in here and we have in on the
I see
root of
that.
the
It's
blade.
like shaded, yeah.
Exactly. Well, manganese bronze is a copper-based alloy that has about 30% zinc in the alloy. And zinc in salt water is an anode. And that's what you're seeing is the dezinkification of the propeller, leaving the soft copper behind.
Okay.
This is a cancer that goes through the propeller and can become very dangerous, especially if it gets into the roots of the blades, as you can see here.
Yeah, I see the shading in the
Yeah.
prop.
Now, I have an example of a propeller that actually
one right
failed due to this. This blade actually came off, and you can see how that demetallization worked its way in and weakened the whole area
Yeah.
of the blade attachment to the hub.
Then the blade went away.
And the blade left the boat.
That's not
Now,
good.
this can be very dangerous, 30 miles offshore.
Very dangerous, yes.
Okay.
All right, so you do the visual.
We do the visual. We'll mark it on the records because we
Okay.
do keep detailed records of every prop we work on.
Okay.
Now what we're going to do is we're going to scan the propeller on the prop scan.
Okay.
Now what this does is we have a computer program
Yeah.
that's been specifically developed around the ISO 484/2 requirements.
Okay.
ISO 484/2 has 4 key categories. You have a Class 3, Class 2, Class 1, and Class S.
Okay.
And there are several aspects to that which include propeller pitch, the pitch of each blade, the pitch of each radii, and your local pitches, which is the fine tuning across the blade.
I see.
We set the propeller up on the equipment.
Yeah.
This rod or this probe will actually ride across the propeller.
Got a little wheel, it's like a pizza wheel there.
Yeah, a little pizza wheel.
Yeah.
And it feeds all the information
Yeah.
into the computer program.
Yeah.
And we will do this on each blade
Okay.
for 5 radii.
5 radii, which
Fi-
is 5 like arcs, if you will.
5 of the arcs, which you can, I don't know if you can see it on the camera, but we have them scribed out
I
here.
see. Yeah.
Once all that data is into the computer, it's presented,
Up on
as
the
you can
screen
see on
here?
the screen here.
Yes, yes. Now I've got like 6 groups of data here. Can you help break it down?
Sure. When we look at the ISO chart, we have propeller pitch. The first thing we look at is the pitch of the propeller what it's supposed to be. Well, this propeller is marked as a 31-inch pitch propeller. And we talked about pitch before.
Yes, we did.
okay? What it's actually measuring is 31 over 31.25 inches of pitch.
Okay.
Now, if this was a twin engine boat,
Yes.
and the propellers were mismatched by 1/2 inch or a 1 inch,
Yes.
it's going to create asymmetrical thrust.
Yes.
And it's going to create a problem with synchronization of the engines.
Okay.
With this equipment and our tuning process, we can actually match those propellers to
Okay.
resolve that issue.
So these colors here, I got green, blue, and red.
Green is blade 1. Now,
Okay.
blade 1 is always the one in line with the keyway of the propeller. And you'll see that on every inboard propeller.
Yep.
Blade 2 is the next one in direction of
Okay.
rotation,
Yep.
because we can have a right hand or a left hand direction rotation.
Right.
This is a left-handed direction rotation.
Mm-hmm.
So the blue line, as you can see here, these little boxes, I hope you can pick it up on the camera, but these little boxes are ISO tolerance boxes for
Okay.
ISO class 1. And that's
Showing
where-
a range.
that's a range.
Yes.
Now, you want those bars within within the box,
Yes.
but preferably as close to the the center line as possible.
Right, right, right.
What you can see here is that this overall pitch of the propeller, the first thing that we look at
Yeah,
here,
yeah.
is almost out of tolerance.
Yes.
Then we take a look at the average pitch of each blade, blade 1, 2, and 3. And we
Yes.
can see blade 1 is 31.225 inches of pitch, blade 2 is 31.339, and so on.
Okay.
They're close to each other, but yet they're not close to the center line here.
Right, right.
Blade 2 is almost out of tolerance.
Yes, yes.
The next thing we look at is the section pitches, the 0.5, 0.6, 0.7, 0.8, and 0.9 as laid out on the propeller here.
Oh, yeah.
And we look at each blade, and you can see they're all high. And as we get out to the tip of the blade, they're sort of inconsistent,
Okay.
which is typical with the tips, because if you go through a piece of wood or something, it can knock the edges, which is
Right.
the thinnest part,
Right, right, right.
out of tolerance.
Yeah.
Once we look at that, we are going to look at one other item, and that is going to be the line graph. Line graph is very important because this is water flow over the blades.
Okay.
The left side of the screen is the leading edge of the blade, which
Yep.
is right down here.
Yep.
The right side of the blade is your trailing edge up here.
Okay.
This is, in this design propeller, this is what we call a flat face constant pitch distribution propeller, which means that, first of all those bars should be the same that we
Okay.
just saw.
Yep.
All of our lines should be flat between the dotted lines here.
Okay.
Where you see the red is where it's out of tolerance.
I see.
So blade 1, which is the green line, at the 0.5 radius, this one here, is actually out of pitch.
Okay.
So we have to bring that all back into pitch.
Yes.
Now we look at each one. That is the 0.5 radius. There's the 0.6,
Okay.
0.7, and 8, and 9.
Different arcs we have there.
From here, what we'll do is we are able to map out on the propeller where those defects are. We can take and look at this. We know where it is on here. We take it from here and we put it on our bending table, and now we start the repair process.
Okay. All right. Well, Larry, once you've got the propeller measured in the computer, this is the next step to actually correct the imbalances and imperfections that you've seen, right?
Yes, we've moved it over to the bending table, and Rich is going to use our high-tech hammers and straighten the blades.
Okay. Let's watch him do it. All right, you do this process for all the imperfections on each blade, correct?
Yes, we're going to go around and use what we saw in the computer graphics to tell us where the defects are. He's going to fix them on all the blades. Once he's done, he'll take and put it back on the machine. We're going to rescan it, see if any more corrections need to be made,
All right, let's go take a look.
see what
I'll
happens.
step out of the view. All right, so we put it back in the jig, if
Yep,
you will.
we're going to put it back on the computer, and we're going to do the same process we did before and
right.
rescan each radii
I see.
on the whole propeller. When we're done with that, we're going to get a computer screen again showing us where things are. Now, for time's sake, we've finished this up, and this is representative of what the finished product would look like.
Right, right.
And as you can see now, our overall pitch is right within the tolerance box. Each blade is within the ISO Class 1 tolerance box. and all of our blade pitches, our individual radii, are right within it, and we get a certificate telling us that we are now in compliance with ISO Class 1.
Beautiful. Well, Larry, once you've gone through the tuning process, I guess the next process is to grind out whatever metal needs to be ground, and then you've got to do the all-important balancing process, right?
Correct, yes. It'll go into the polishing room after we get the blades accurate, take out any hammer marks, any imperfections. If we had to weld on it, we'd grind the welds out, and then we put it on the balancer and polish it out.
Okay.
And of course, the balancing is as critical as it was previously when we talked about the outboards.
Any prop you work with,
This is just a little bit larger balancer than the one you saw previously.
Okay, and the whole idea is just to make sure that you don't have any blades that are out of tolerance, and you actually can etch the name of the boat or your company into these blades, can't you?
Well, that's kind of our trademark. We do etch in the Accutech name on one blade, and then we etch in the boat name on the other. And our customers really like that.
That's a nice touch. And then finally, I guess you polish it out just like it looks right now to make it look like new, right?
Yes, exactly.
Well, Larry, it's tough to believe, but time to wrap up the show. And we've covered a lot of information here today about the different activities that happen within a professional propeller refurbishment repair shop. Is there anything you'd like to add before we wrap up the show today?
Well, there's so much more that we could show you, but obviously for time constraints, we can't. But propellers are extremely important. It's propellers that move boats, not motors.
Right.
And since they're out of sight, out of mind, a lot of people don't think about them until something actually catastrophically happens.
Yes.
We recommend that props come in at least every couple of years for inspection. Because again, like I say, you don't want to be 30 miles offshore and lose a blade. It gets a little expensive.
Yes, yes.
So, you know, routine maintenance on propellers is just as important as any other routine maintenance on a boat.
If they have questions, really, regardless of where they are in the country, they could probably find some useful information on your website, right?
Yep, our website is continually developing, or they could call us.
Okay, all right. And you're under Accutech Marine Propeller in Dover, New Hampshire, right?
That's correct.
Yeah, okay. Larry, thank you.
Thank you.
And thank you, Smart Boating viewers, for joining us today. If you have comments or questions, please visit our website, www.smartboatingus.com. Thank you.